Right. Good afternoon, everybody, or good morning if you're on the West Coast or wherever you may be. I'm Dave Broadbent, ABYC's Education Director, and you see our former Education VP, Ed Sherman, who I always enjoy sharing the screen with, who's going to be presenting on some AC troubleshooting and shore power today. We are in June now. It happens to be June 4th, which my wife kindly reminded me is our wedding anniversary, so that's great. And I think everyone's starting to pick up, depending on where you are. Hopefully, business is picking up with things shifting here. So let's go through a couple weekly updates. We're headquartered down in Maryland, so there are some restrictions that are starting to relax for us down there. So if you've had any issues with contacting us, we've all been working hard, but our phones will be answered a little better off and things like that. So keep your eyes out for that. We're continuing to do whatever we can to support everyone out there, including these webinars, which have been great, and I think everyone's been enjoying them, so we're not stopping anytime soon. Feel free, any tech questions you have, as always, membership, education, we're all working hard. Give us a call. We'll gladly help you out with anything you need. As always, the registration is offered first to our members, so it comes out Tuesdays. So if you have any questions about membership or benefits, definitely reach out to us. And definitely, if you have any topics, we'll gladly get into those as we go on with this series. CEUs, same as it's been for the past few weeks. If you're watching this live, you'll get a follow-up email tomorrow at 1 that will have the link to apply for CEUs. Simply just log in, answer the one question, and it'll be applied to your transcript for you. If you're watching this on YouTube, there'll be a link that pops up on the end here of the video that'll allow you to apply for CEUs. Some of the online resources, covering them again, we have our standards online. We have some of the work resources for our instructors. Our fundamentals textbook is free through August. Just reach out to us or go to teachboats.org. And thanks again for AIM Media for helping us with that. If you're interested in an instructor, you can go to teachboats.org and kind of get on an email list for things too. And one thing that's pretty cool that myself and Ed are working on, I think it's my first time mentioning it, is we are going to be developing a new workbook that goes along with the textbook. So keep your eyes out in the next few weeks, months for that. But it will be ready for the upcoming school year. So it's a really exciting thing that we have put together. Self-study certifications, as always, you can get certified from the comfort of your own home using ProctorU. You just need a webcam and a microphone on your computer to do that. We did launch some new free micro courses, so look out for those emails. I believe one of them was battery tie-down systems, so that's a good one to take a look for. And we do have our new learning management system. So if you have any issues as you log into that, it's growing pains, but I'm telling you, it's going to be a lot better with our new Elevate platform. Our interactive classes. So we have scheduled all of our classes through the end of 2020 with a couple that are still floating out there that we're looking to get in the calendar. But basically, if there's a class you want, there's an opportunity to get it in an online format within the year here. So you can go to abycinc.org/schedule and take a look at all of the offerings, as well as the laundry list of this is now our 10th Thursday webinar. So all 9 previously, as well as this one, will be linked there if you have missed any of them. So feel free to take a look at those. And with that, I am going to turn it over to Mr. Ed Sherman to get us rolling here. So Ed, you should have controls coming your way.
All right, I got it.
I'm going to drop off my webcam here.
Okay. I'm assuming that the screen is not looking for you folks like it looks for me, but anyhow, we're going to talk a little bit about shore power troubleshooting today, and I'm going to show you some of the tools that I use. Many of you have probably seen these before, but I don't often go through step by step what some of these tools actually can show you, and it's a little bit of acronym soup, so I can explain some of those and what the readings on your machine might tell you. So let's get right on it. Because this is shore power related and high voltage, I'd be remiss if I didn't just begin with a little bit of basic AC safety. We are talking about voltage and amperage here that could conceivably kill you if you really make a bad mistake with it, and so you need to be cautious. And in my experience, because I've done it myself, you know, the more you work on AC systems, the more laissez-faire you tend to become relative to the whole safety side of it. You just have to constantly remind yourself that you can literally get zapped at any moment if you're not careful. So these safety recommendations are very real. This particular bullet point needs some explanation. Use only marine grade products, and I'm referring to the wiring and things like terminal strips and connectors. You know, in terms of light switches and AC receptacles, the gear you're using is for all intents and purposes the same equipment that gets used in a residential or in some cases, you know, business type or commercial application. You know, I realize that companies like Marinco sell what they refer to as, you know, a marine rated receptacle, but they're really not very different from what you could buy at Home Depot, quite frankly. And I'll talk more about this in a little while because it is one of the potential areas where we can run into problems based on the wire that we use. It's very important to observe the polarity at all times when you're running through the boat and installing equipment. You can have reverse polarity set up at a receptacle and have everything else on the boat be fine. So you need to make sure that you're cautious of where the hots, neutrals, and grounds get connected. Disconnect the power at all times, except when testing for voltage or amperage. Make sure it's totally shut off. You know, you can get tricked. The biggest trick is an inverter that's in sleep mode hidden somewhere. It's one of the reasons why we require some indication that there's an inverter on board to be near the main panel board, on or near the main panel board. Should be common sense here, but I'll say it anyhow. Never work on the system with wet hands or feet or when the components are wet. Make sure the boat is connected to a proper and tested ground, even when working with the power off. Rubber-soled shoes. Keep the distractions to a minimum. GFCIs, you know, they say right on the device, test it monthly. And I can tell you that historically, this is one of the components that has a very high failure rate. The newer units, and I think we're probably on the third, maybe even the fourth generation of ground fault circuit interrupters out in the marketplace, are much better than the early ones. But most boats that you're going to get on board have got GFCIs that have been on there for a while. And depending on the vintage of the boat, they could be quite old. And I will tell you, in all probability, they're not functioning as they should. They've got a very high failure rate in the marine environment. It should be obvious. Disconnected or clipped off grounding conductors should be corrected immediately, and pay attention. So the need for electrical testing, some years ago, it's been a while, Boat US did a survey that indicated that 55% of all boat fires were caused by electrical system faults. And I'm not positive on this, but I'm going to bet that the highest percentage of that 55% was related to shore power systems or AC power. So we'll focus on that today. We're not really going to talk about DC at all today. So other items, is the vessel connected to shore power? And even if unplugged, again, the inverter is a real possibility. It's happened to me, I know. And the other one that many of you probably experience, a vessel on land, it's up on the hard, and you go over to the boat and you touch the prop shaft and you get zapped. It is plugged in. Don't rely on the grounding system at a receptacle out in the back 40 of the marina. Odds are really good that the ground is not good. Assume that a problem exists. And the other item is, even though the color coding for AC systems is pretty well established globally, the ABYC standard recommendation for colors on AC is mirrored throughout the world in the ISO standard. Different countries favor different colors a little bit, but they're all identified within ABYC's E11 standard. And but assume nothing. I recall several boats that I've worked on over the years that used green conductors, which we normally assume to be grounding conductors, not normally current carrying, that actually turned out to be hot wires, or as we refer to them, ungrounded conductors. It's just mind-boggling. I mean, somebody ran out of the right color that week, and there it was on board the boat. So again, be careful around inverter chargers. Water heaters, I've been zapped by quite a few of them. The old Raritan 6-gallon water heater. Still plenty of boats out there with that type of equipment on board. It's a mild steel case painted, but the grounding tab on it it's just basically a piece of sheet metal, and they do have a way of rusting out, disconnecting the ground. And if you get a short circuit in the heating element, which is not that uncommon, the case can become live, and it's a reasonably common problem. So test it with your multimeter to see if you get a voltage reading between the case and a good ground, like the engine block or something like that nearby. If you get a voltage reading, and it might not be 120 volts, but if you get an AC voltage reading, be careful. It's a live case. So the 4 bits of equipment I'm going to talk about today are the Ideal Short Test tool, which is probably one of the greatest tools created over the last 20 years, in my opinion, because it enables us to do things that we just couldn't do prior to its creation. An AC leakage clamp-on ammeter, and I have to emphasize the fact that it should be of the type that is geared up to measure AC leakage current. And when I say that, we're looking at very small values. For those of you that do AC work, understand that today we have a 30 milliamp whole boat protection requirement via the ELCI devices. 30 milliamps is not a lot. I mean, there's 1,000 milliamps in 1 amp of AC current. So unfortunately, this also means that you're not going to be able to effectively check for AC leakage with your standard AC clamp meter. It just doesn't have the sensitivity you need. For years, I used a digital pyrometer to measure temperature gradients. I'm now using a thermal imaging camera, a FLIR unit. The one you see is actually on screen, the one I use. Another good one that I haven't personally used, but I've been told works very well, also made by FLIR. They have one that will clip onto the back of your iPhone or Android device, and I'm told the resolution's quite good. And we're looking for temperature differentials from one point in the circuit to another. It's easy to explain. You know, a byproduct of electrical resistance is heat, and it's measurable. So we'll look at that a little more in a few minutes. Let's start out with the Sure test, because it's one of the most comprehensive test tools out there, and it's incredibly easy to use once you understand what some of its limits are. To begin, you're going to need to make up some adapters because it comes with a 15 amp plug. So you're going to need a 15 to 30 amp, and you may have to make up a couple of adapters if you're going to be working with 240 volts, L1 neutral and ground, L2 neutral and ground, separated out with two adapters so that you can plug the 15 amp attachment cord into that and take some measurements. But once you do that, it's just pushing the buttons on the front of the machine. So let's go through this step by step, and I'll explain what we're seeing on screen. The back side of the device has, you know, sort of a decoding chart that tells you what the lights you see on the front are indicating. I get a lot of questions about a false ground. What is that all about? And a false ground is a neutral to ground link on board the boat. So you need to be cognizant of that. The instructions that come with the Sure test will tell you that it can measure or detect a false ground within 15 feet of the device, assuming a straight wire run. In my experience, it'll actually work a little farther away than that, but you need to know what a false ground is, because if you're checking, for example, a shore power pedestal, not on board the boat yet, and I always check the shore power first, there may be a transformer on board the or on the dock feeding the shore power receptacles that has a neutral to ground connection at the transformer, and it could conceivably be close enough to give you a false ground reading. I think the others are pretty self-explanatory. An open ground, also a very common occurrence, which is what gives us a lot of the problems that we actually have. So you've got that, and then the front of the machine or meter is actually showing you the, you know, the light configuration, the LEDs, and once you get through this point, you just hit the down arrow button, and it'll immediately show you the true RMS line voltage at the point at which you're checking it. So here we have, you know, 119 volts. I mean, understand that you're not always going to get 120 volts. You won't. You know, the tolerance based on ABYC standards is plus or minus 10% of the nominal rating. And, you know, and it will vary throughout the day depending on how much of a load there is on the grid, you know, in proximity to where you're testing. The next test is neutral to ground leakage and hot to neutral leakage, typically caused by either a bad installation or insulation rather, or maybe a salt bridge at some terminals. According to ideal, less than 2 volts AC is considered acceptable. So here we see, you know, 0.9. I don't remember where I was testing it, quite frankly, but and where I got that reading. But don't be surprised if you get a low-level reading like that. It's not cause for great concern. AC peak voltage is kind of interesting. If you had an oscilloscope, this would be the voltage reading at the very top or bottom of the sine wave peak. And this has some value to us from a diagnostic point of view. It can help us to determine if there's an extreme amount of harmonic distortion in the power feed. You have to compare your measured reading here to what the line voltage was. I think, as I recall, we had 119. We multiply that times 1.414 to determine what we should get. And if you've got more than about a 2 to 4% variation, you're actually looking at what can simply be described as some distortion in the AC power feed, which again, unfortunately, is not that uncommon and can create some problems on board, particularly with things like audio amplifiers and stereo equipment and things of that nature. You get low-level hums in the background and symptoms like that. So it's a way of making a quick determination about possible line voltage distortion that you would normally need much more sophisticated equipment to even think about troubleshooting. But this will give you a clue. Frequency, of course, is important, and I mean, this is terrific because if you're installing generators or testing an onboard generator, the frequency and voltage is directly connected to the RPM that generator is running at, and by golly, you can test it right to the point and make sure that everything's as it should be, 60 hertz here in this country. Voltage drop is probably one of its greatest strengths as a tool, and it'll measure at I think 3 points, as I recall: 10 amps, 15 amps, and 20 amps. You don't want to see any more than 10% voltage drop from the norm. And what's indicated here, and it'll measure for both the hot, neutral, and ground, is either a bad connection or wiring that's undersized. And that's what we're trying to determine. Now, of course, the problem with that, if you're measuring on the dock, is that it's giving you a total reading, and to isolate where the fault is a little bit challenging because you really have to work your way down the dock towards the source of power to isolate where the problem is. But I'm not aware of any other tool other than, well, there are other tools like the ideal short test, but I mean, with this, you can actually determine if you've got too much voltage drop. Again, for voltage, the maximum ABYC allows is 10% plus or minus. Frequency, 5% plus or minus. With frequency delivered by utilities, I rarely see any issues at all. I mean, it's spot on. But with an AC generator on board, different game. It'd definitely be an RPM issue, governor issue. Available short circuit current is one that confuses a lot of people. This is a situation where a big number is a good number. Again, wire sizing and terminal integrity is what we're alluding to here. It basically is telling you how much AC current could be delivered to the point at which you're checking it. And a high number is a good number. A low number, again, implies possibly bad connections or undersized wiring. So it's a good test. And then the last three tests are actually checking the capability of a GFCI or a GFP device. And this one is showing me that I've got a GFCI that only tripped out at 7.3 milliamps, which implies that it's defective. I mean, a GFCI device that trips out at more than 6 milliamps is a defective device. You have to unplug it and then re-engage it to find out how many milliseconds it took for it to trip, which is another indicator of a problem. If the trip delay is too long. This will also measure a 30 milliamp device, so pretty handy information. The parameter, again, heat equals electrical resistance. So we're looking for excessive heat. And the way I make a determination on that is to track the red dot from the device down the length of a conductor until I get toward the point at which it connects to either a bus bar or a terminal. And if I see anything greater than about a 25 Fahrenheit increase as I get near the terminal, well, that tells me there's a problem there. And in some cases, if it's a heavy, and the problem with this is you have to have some current flowing to get a reading. But for years, I used the digital parameter you see right there, and would track it down, looking for changes in temperature. Quite useful. Today I use, the FLIR gun, and in this case, you have to be very careful because what looks horrific may or may not be. I mean, what you're looking at in this picture is, a shore power cord going in, and that's the main plug entering into the boat, which is terrific. But it's very bright and it's scary looking. Well, in this case, there is a problem because it's over 45 degrees Fahrenheit warmer than the cord itself, which indicates a resistive connection. Not uncommon. You've all looked at the end of shore power cords that have, got black and charred or partially melted sections of the plug assembly around the terminals. What causes that? Excessive heat, bad connections. So don't let the color alone be your guiding light. You really need, in my case, I use FLIRView software, which I just load onto my flat screen on my iPad, and I can analyze the exact temperature at any point in the picture, and it'll show me. So it's great technology, and it really saves you a lot of time in troubleshooting. But you do have to be cognizant of the fact that the colors can be scary and not necessarily indicate a problem. So yeah, here's the comparison on this particular piece. That the cord was only 93 degrees Fahrenheit, 45-degree difference. I use 25 as a degrees Fahrenheit as a benchmark. If it's greater than 25-degree variation, I'm concerned, and I will look to see what's going on. All right, the clamp-on AC leakage meter. again, this I'm connecting this, and it looks like I'm using the meter the wrong way. I've got it around the entire shore power cord. That's the way you do want to use it. We're looking for a differential between the hot and neutral conductors. And in this case, I'm looking at 6.62 milliamps. Not necessarily a problem, depending on what equipment is turned on board the boat. It's not uncommon to see some low-level leakage, particularly on newer boats with digitally controlled power sources. They have some inherent leakage, which is normal. But all that said, international standards only allow for very, very low levels of ground fault leakage back into the system. 1 milliamp, maybe 2 milliamps, no more than that. And, you know, per appliance. So it's, you know, it's not going to be an issue. That's where the 30 milliamps came from. We know that depending on the size of the boat and how much equipment is installed, getting, you know, upwards of over 20 milliamps of leakage current is conceivable, but it's not necessarily indicative of a problem. So you need to be aware of that as well. The downside of this particular test methodology is that it's a process of elimination thing, and you really have to do it just that way. You've got to turn things on and off and look for changes. If you get to a boat, for example, and you clamp it and you don't have any leakage, and then all of a sudden you start turning appliances on and the leakage current continues to rise as you turn more appliances on, it's typically indicative of a neutral ground connection somewhere near the AC panel board, which tells me that the boat may have been worked on by a residential electrician who may have been trained to actually do that in a land-based installation. It's not something you want to do on a boat, because what happens is the neutral conductor, the return current, now starts using the ground as the grounding conductor as a possible path as well. And so the more appliances you turn on, the more current gets dumped into the green wire. It's very easy to create a potentially lethal scenario around the boat under those circumstances. So that kind of covers it. I'm open for questions now, and Dave, I need your advice on how to hit show screen. Yeah, there I am.
Yeah, you're good. So as always, we do have a trivia question here. I'm going to get going in a second, and I apologize for those who are new to this or this is your first webinar. If you want to ask questions to Ed, there's a little question tab on the right-hand side. So feel free to start typing those in, and I'm going to get our trivia question going here in a second, and then we can get to some questions. So give me 1 second here to pull it up, and we should be good. All right. All right, I'm going to select. Bam, so there is our poll. All right, Ed, looks like most people are paying attention here. And question said, what was the tool that you said was the most useful for AC testing? So the correct answer is Ideal Shore Test. So 89% of the people got it right there. So now we can get into some of the questions here. How different is a grounding system on a metal hull boat?
It depends on where the boat is. In commercial applications, it's very common to use what we refer to as ungrounded boats, where everything is isolated from the hull. It may be changing at this point, but I know, for example, in Canada, that on certain categories of vessels is actually a requirement. I'm not sure how that's evolving at this point. ABYC doesn't even talk about ungrounded systems. It is a topic in our new advanced electrical certification for sure, because we do see it on some bigger boats and certainly metal hull boats. But the E11 standard currently refers to grounding on metal boats occurring at one point, and from the engine negative terminal to the hull, the inside of the hull, at a point above the bilge high water mark, and that's it. That's the only place where we require it within the standard.
Right. Can you use a TurboTech circuit analyzer in European dock pedestals?
I'm not familiar with the TurboTech analyzer, so I don't know the answer. I need more information on the TurboTech.
Right. Ed, could you explain the dangers electrically of using a portable Honda generator?
Electrically. Well, historically, the problem was no neutral to ground. And I have heard that they have made a kit and that has changed, although I haven't personally checked one myself. I think the biggest danger with the portable generators is carbon monoxide. And I've seen so many installs where I was quite concerned about that. The most common problem when you utilize one is to have a faintly glowing reverse polarity light, and that has to do with the neutral to ground link. It becomes a source of power, so a neutral to ground link is required at sources of AC power. Okay. And, historically,
oh, still going, Ed? I'm sorry.
No, historically, they just haven't done that.
Mm-hmm.
That may have changed. I think it has changed, actually, but it's a carbon monoxide risk that needs to be avoided at all costs.
All right. This is an easy one here. Has ABYC considered offering other electrical tools at special member rates, similar to what we've done in the past? I can tell you the short answer, yes. We're constantly looking for tools that would benefit our members and working with member companies to make that happen. And so keep your eyes out in the next few months. I'm sure we'll have another one coming down the pipe. Have you seen an ELCI break down?
Cease to function?
I think that's what he's going for.
Yeah. I can't say that I have. I mean, the latest generation seems to be performing pretty well. I'm not hearing any complaints like we did early on. I mean, early on, it was a horror show. They weren't failing, they were nuisance tripping. And it was a very real thing because they were nuisance tripping. But I believe we've resolved that. because I haven't had any complaints in a few years. So I think the failure rate's quite low, frankly.
All right. How much voltage leakage is considered acceptable when testing with an ideal sure test GFCI and AFCI tester?
Well, 6 milliamps is the National Electric Code max for a GFCI device. Okay, if they're rated nominally at 5 milliamps, it should trip out no higher than 6 milliamps. Understand categorically with circuit breakers of all types, their nominal rating is just that, a nominal rating, and that they will typically actually not trip out until it's a little higher than the nominal rating, and that varies a little too. In the case of GFCI specifically, it's 6 milliamps.
With an isolation transformer on board, what are the things to consider when measuring current leaks?
Current leakage, was that the word? Yeah.
Yeah, it says current leaks. I'm assuming leakage, yeah.
Yeah, okay. Well, the good news is, if it's a true isolation transformer, it's going to stay on board. And it's not going to get dumped into the dock wiring system because there's no hardwire connection between the primary and secondary sides.
And I think a follow-up that fills in nicely here is, should there be a neutral to ground bond on the boat side of an isolation transformer?
Absolutely, yes. It becomes a new source of power.
All right. The ASCC tests include one that will trip the breaker. Please explain.
Available short circuit current. Is that it?
I believe so.
Yeah. Repeat the question.
It says the available short circuit test includes one that will trip the breaker. Please explain.
I've not used it for that. I think you're thinking about the GFCI test.
If you had that question, you could submit something, clarify if you'd like. Let's see. What adapters do you recommend for the short test?
So minimally, you're going to need a 15 to 30 amp plug adapter, and you, depending on where you're working, may want 15 or 20 amps is going to be okay. You may want 50 amp adapter set. So again, you get two 50 amp plug assemblies and label them and wire them for L1 neutral and ground, and then the second one would be L2 neutral and ground. That's the kit that I use. Now, if you're working on bigger boats with 100 amp service, while you're in a whole new realm, you'll have to add some additional adapters. And I will tell you this, that if you're working on European installations, be careful. You've got to, you really have to study the wiring and make up a custom adapter if you're so inclined. I learned that the hard way in Australia and tripped out a whole whole hotel with an ideal short test. The hots, neutrals, and grounds are there. They're just connected differently. Can't use the US configurations.
All right. what is the best method to track down a neutral to ground connection on board? Process of elimination?
No, it's actually pretty easy. And you can do it with a multimeter. You don't necessarily the short test. Again, that's your false ground reading, and it'll indicate a false ground. And the false ground will somehow be associated with the plug that you're plugging in, or the receptacle that you're plugging into. You could do the same thing if you're sure that there's no power on the boat. Use your own meter and just plug in hot and neutral, or neutral and ground rather, and see if you get continuity. And do that at a bunch of different receptacles. And if you get continuity, there's a neutral to ground leak connection there somewhere. If you get it at a bunch of different receptacles, it's probably at the back of the panel board at the main bus bars.
All right. What is the difference between an isolation or a polarization transformer on board?
Huge difference. With the polarization transformer, the grounding conductor is continuous from the shore to the secondary side of the transformer. And we call it polarization because it eliminates the possibility of reverse polarity on the secondary side of the transformer. It's self-tending. It takes care of itself. An isolation transformer, conversely, the grounding conductor is not continuous to the secondary side. It ends at the shield, in the transformer. It doesn't go to the secondary side at all. So that's why we have a neutral to ground connection on the secondary side of the transformer in an isolation transformer scenario, because it becomes a new source of AC power.
Right. What kind of leakage current would cause electric shock drowning?
Well, it doesn't take much. We have established 30 milliamps of leakage current as a max acceptable. That's global. It's universal around the world. And anything above that is a risk, and it will vary dramatically depending upon the person involved, and their physical health, their physical size. All of these things play into it, but 100 milliamps, let's say, is almost assured to be lethal. Excuse me. So 30 milliamps is our standard, and we're sticking to that. I mean, because it's going to vary a lot depending on, is it a 5-year-old child? Is it a 50-year-old female? A 300-pound male? All of these things are factors that play into it. There we go.
All right. Does a dimly flickering reverse polarity light always indicate a problem? In this case, I measured less than 2 volts, but it's enough to light the LED dimly.
Yeah. Yeah, that is indicating a potential problem. Depends on the vintage of the boat. One of the issues we had early on with older boats was just that, a dimly lit reverse polarity light. And what they ended up doing was modifying the light control. So we ensure a minimum of 25,000 ohms separation, so that to mitigate the faintly glowing light. It was a big problem for a long time with a lot of boats, and it was more about the light itself and the way it was wired into the boat than it was necessarily a real problem with the boat. So, I give that a maybe or an either or. It depends on the vintage. I think it's a problem that we've very successfully taken care of on new boats without any issues.
Right. For a basic pre-purchase valuation survey, what is the minimum electrical test that should be done? It says for AC, DC, but we could stick with AC since that's the topic.
For a survey, I think it's very important to, look for the obvious, wiring that could conceivably cause an electric shock hazard. The other question that I get a lot from marine surveyors, and it's a very valid question: what about the older boat that isn't wired with a grounding system, which is there for personnel protection? It's a 2-wire AC system. There's no green wire system on the boat. Should that be updated? And my answer to that is, I would recommend yes, but I say that with a caveat, and that is, if it's a classic or antique boat, the owner may very well not want to update it, and I get that, but I'm still going to write a report that will say my recommendation would be to update the system to an AC grounded system with appropriate ground fault circuit interrupters installed where standards require them. I'm still going to make the recommendation, but I still run into boats. One of the things I've done annually for quite a few years now is be a judge in the Antique and Classic Yacht Rendezvous down at Mystic Seaport in Connecticut. And, you run into these boats, they're 60, 70 years old. They've got a shore power system on board, no grounding system, and they don't want to change it. It's still their choice.
All right, and the last question is kind of a two-parter for you here. Do you know what model your FLIR is? And to go along with that, do you have an idea of all the products you talked about, kind of a cost of what each of those generally cost these days?
Yeah, the IR7, which is the FLIR unit that I'm using, the prices have dropped dramatically. I checked, in fact, a couple of weeks ago, and I think you can get one of those for about $800 or $900 these days. At the time I bought that, it was like almost $2,000. The unit that clips on the back of the phones is about $400. The shore test, you're looking at just under $300. A digital parameter like the one I'm using, 20 or 30 bucks. What else did we have on the amp clamp, the AC leakage clamp? That's one of the devices. The one that I show you is the one that I bought years ago, and it's no longer available, but it is one of the tools that we had a special sale on through ABYC, and that one is made by Megger. Do a search for that. I forget the part number, but it's a Megger AC current leakage tester. And I think you can get that now for I want to say just under $300. So,
And if you want to, you could shoot me an email. I know we did have a sale on those. We probably won't have another one on that anytime soon, but I could at least get you over the model number of that, anyone curious. And that kind of brings us to the end here, Ed. So once again, Ed, thanks again for coming on. I know everyone appreciated it. Thank you all for asking questions. If you're watching live, once again, you're going to get your notification for CEUs in email tomorrow with some additional links of some of the things we talked about today. If you're watching on YouTube, Matt will make a link pop up somewhere on the screen right now. And click on that link and you'll be able to get your CEUs through that. And beyond that, I will see you all next week. Thanks for attending, and thanks again, Ed.
okay, bye for now.